Hello everyone, welcome again to my YouTube channel. And today's video we will learn a little bit different in Excel. Here we have a numerical which is totally linked to the geotechnical engineering, which we will solve using the Excel sheet. So here we have a problem which is a data acquired from the field as well as from the laboratory. So here in the problem we have a soil mass that is 128 grams, and the height of the sample as well as the specific gravity and the area of the sample. Here we have a table. In the table the pressures as well as the height at each pressure. So using this data we will be able to draw a wide ratio and pressure curve, or a kind of a graph. So here we have a data. Coming to the other tab, that is the consolidation, we have data here: the effective pressure, the height at each end after consolidation, and the HV as the wide height and E is the wide ratio. So we will calculate all of them. First of all, we have the effective pressure and the U and the wide ratio, which we will use for the purpose of a graph. So the specific gravity is the GS, which is 2.75 from the data, and mass of the soil, that is 128 grams, and the initial height of the soil sample, which is 2.454 centimeters, and the area of the specimen, that is A, 30.68 centimeter squares. Now we will calculate the HS. So what is HS? That is the height of the soil samples or the soil solids, which can be found through the formula, that is mass of the soil sample divided by specific gravity into unit weight of water into area of the specimen. You can see here. Now calculating the height of the solids. So height of the solid is the mass of the solids, that is mass of soil, and the unit weight as well as area and the specific gravity. So writing a formula here for the height of the solids, which is this one. So first of all, I will add the mass of the solid or mass of the soil, which is 128, divided by the specific gravity, and the specific gravity is also given in the above cell. So specific gravity of the cell is 2.75, and to unit weight of water is known, that is 1, and area of the cell sample, that is 30.68. Clicking enter. Now you can see the height of the solids. So this is the height of the solids through which we will be able to calculate wide's height. Writing here height of solid HS. So this was the required height of solids. Now we can calculate the HV through HS. The H, that is the height at end of the consolidation, and HS is the height of the solids. So writing a formula, that is equal to the cell minus HS, this one, and now you can see, keeping it as constant because we need the HS constant throughout the cell. So we will add here the dollar sign and drag it down. Now you can see the wide's height up to 0.60. On the other side we have wide ratio. So wide ratio is the height of the wides to the height of the solids, which is equal to height of wide divided by height of the solid, that is given already here. So this one is the height of the solid, keeping it constant, adding the dollar sign here, and now you can see that is the wides ratio, keeping it up to 2 decimals. So I'm keeping it up to 2 decimals. Now you can see this one. Now I want to create a graph, a line graph for the data. Here we have two kinds of data, the effective pressure and the required wide ratio, which we have calculated through the formulas. Now recommended charts, let's see. So this chart is, we will use this one, and okay. Here are some values. On the right side here as the wide ratio, and on the left there is an effective pressure. Dragging it down to keep it as a little bit bigger, selecting the data. Now you can see that is the effective pressure on the bottom, and on the left here is a wide ratio. So clicking, formatting the chart, what can I do? Clicking the right and format the axis. After, here you can see, keeping it as logarithmic scale. Okay, now the data is converted to the log scale from 1 to 10,000. Again, formatting the chart. So right click and format the axis, adding the minors. So that's how we can add the minor lines to the graph. Here's the minimum value is the 1, so I want to keep it as up to 10 because my value is starting from up to 50, so therefore I'm keeping it as 10. Now you can see it starts from 10 to 100 and so on. Here you can see the 50, and the corresponding value of the wide ratio is 0.64. On the left side we have a wide ratio. So again, formatting the cell, like for the pressure one, the minimum is, I'm keeping it up to zero point 0.2. Let's see the result. Okay, now we have a lot of space here again. So to keep it as, to keep the uh, graph or the chart clear, I'm adding 0.3. Now you can see the whole chart has been covered with the line. Adding a little bit the text, the titles. So this is the wide ratio. I'm writing here wides or wide ratio, and here I can write the effective pressure in kilonewton per square meter. Now you can see that I have added the titles, as well as I want to edit this one. So it is the wide ratio versus effective pressure. Writing here the wides or wide ratio versus the pressure. This pressure is the effective pressure which is applied during the laboratory test. So now you can see I have created the chart, and this chart can be used for elaborating the relationship between wide ratio and the effective pressure. You can change the color of the chart, as well as you can format. So hope you got this video tutorial which is beneficial for consolidation. Thanks for watching.